Lesson 2.3, Functions versus Relations. What is a relation? A relation is any relationship between two values. It's typically represented by an ordered pair, and it is defined by an equation, an operation, or any other mathematical rule. If you think about a relation as a relationship in your general life, that could be the relationship you have with family members, friends, schoolmates, co-workers, the clerk at the store, any kind of relationship. And you and that other person would be the two values. A function is a special kind of relation. Each x value can only have one y value. So if you think about relationships, we've got, like I said, you've got your family members, you've got your friends, you've got colleagues, co-workers, other students, random people on the street. The function would be a special kind of relation. So each x value can only have one y value. If you think of a y value as a mother, a birth mother, every kid can only have one birth mother. You can't have been born from multiple people. So if a kid is the x value and the y value is the mother, that's the function. Now, the mom can have more than one kid. It's just that the kids can't have more than one mom that gave birth to them. So you could think of it that way. That's a function. Functions and relations can be expressed in many ways. Equations, sets of ordered pairs, graphs, tables, or something called a mapping. The x values in the relation are known as the domain. The y values in the relation are known as the range. Our domain is where we come from. You know, you think about your house as your domain, and then your range is where you go to, all the places you go. So the values start in the domain and end up in the range after whatever the relation rule has happened. The domain is the set of input values, and the range is the set of output values. The domain is also the set of independent variables, and we talked about independent variables in our last lesson. And any value can be selected and input into the equation representing the relation. So you can pick anything out of the domain. And then the range is the set of dependent values, and that value will be dependent on the one that you had selected from the domain. So if I pick a 5 out of the domain, I'm not going to get just any number in the range. I'm going to get a very specific number that goes with the 5. So to represent functions and relations, we have a couple different ways. We have sets of ordered pairs, mappings, tables, graphs. We also have equations. Okay. A set of ordered pairs will look like this. These brackets indicate that it's a set, and the numbers in the parentheses the ordered pair. Okay. We can have a mapping, which is where we have two boxes. The first box will represent the domain. The second box will represent the range. All of our domain elements, all of our range elements, and the mapping has arrows to show which numbers go together. So 2 and 3, -1 and 5, 0 and 3, just like with our ordered pairs. We can have a table of values. Our x values are listed, our y values are listed. We can have a graph. If we have a graph, we'll have a set of coordinates. So we'll have 2, 3, -1, 5, and 0, 3. This would be our graph of this relation. Oops. Just ignore that line. Determining if a relation is a function or not. In order to be a function, an x value can only be associated with one y value. So again, this would be a kid, and this would be like a birth mom. So every child can only be born from one person. So if we have a function versus a non-function, we have our domain and our range in both sets. Okay, domain and range. So if we have a function, we will have a situation that maybe looks like this. And if we have a non-function, we might have something that looks like this. Now you'll notice the difference between these two. Here are all my x's, these are all my y's. Each of these x's only goes to one y. One arrow, one arrow, one arrow. So we have one arrow each. Over here I have my x's and my y's. I have one arrow, but then I have two arrows and two arrows. If I have more than one arrow on an x, I am not a function. So no x value can result in more than one y value. Another way we can determine whether a relation is a function or not is that we use what's called a vertical line test. If we have a function versus a non-function, here's my function. Oops, sorry about that. If I run a vertical line along the graph like that, our line will only touch the graph in one place at any time. So if I were to be able to pick this line up and slide it across, or I can look at these coordinate lines, and as you can see, there is no place where a vertical line is going to touch this graph more than one time. If I have a non-function and I run my vertical line across, as you can see here and here, I'm touching in more than one place. So if my vertical line touches the graph more than once, it's not a function. And it could touch it twice or 10 times depending on what the graph looks like. But if it touches once, it is a function. If it touches more than once, it is not a function. So let's look at some examples. Are the following relations functions or not? We have two examples here. That should be that. Okay, so I find that the easiest way to start is by creating a mapping. We're also going to name the domain and range here, just to get some practice in for that. Okay, so I'm going to start by creating my boxes for domain and range. I have a box and I have another box, and no, they don't have to be pretty perfect boxes. My domain is all of my x elements. So I have a 1, a 4, a 2, and a -3. My range is all of my y elements. So I have a 3, a -6, a 5, and then I have another 3. But we only list each number one time. So if I already have a 3, I don't need to write it again, because a 3 is just a 3. It doesn't change. Now I create my map. 1 went with 3, 4 with -6, 2 with 5, and -3 with 3. Once I've drawn all my arrows, I then look at my domain. I have 1, 1, 1, 1. So each x has only one arrow. So this is a function. Okay, and here's my domain. So if we were going to name that officially, we would list our domain elements in a set. I have 1, 4, 2, and -3. And we would list our range elements. I have 3, -6, and 5. Okay, now I made a correction here. That should have been a negative. So we're going to start with our mapping. We make a domain box and a range box. And in my domain, I have a -3, another -3, and a 2. And in my range, I have a 2, a -6, and a 0. I will draw my mapping. So -3 went to 2, and -3 goes to -6, and 2 goes to 0. I don't know why that's there, just ignore that. I have 2 arrows here. So we have more than one arrow. So we are not a function. Now, even though we're not a function, we are still a relation, so we still have a domain and a range. My domain is the set -3, 2, and my range is the set 2, -6, and 0. Okay, finally we're going to apply the vertical line test on these. Okay, for my vertical lines, I'm going to use these lines going down right here, vertical lines. And as I look, I go, okay, this one doesn't touch at all. We have 1, 1, 1, 1. So far we're okay. And then, uh-oh, 2 spots where we're touching. And since we're touching in more than one spot, okay, the word more has an E on it. They're not a function. Here, if I come along, I go, okay, that's good, good, good. And as I can see, I'm not going to touch in any more than one spot. So I have one spot only, or one spot each. This is a function.